Welcome to the first in our 2025 season of designTimber webinars. My name is Matt Milton. I'm Editorial and Publications Manager here at Timber Development UK. In a minute, we'll be hearing from the team behind the Centre for Advanced Timber Technology. But just in the meantime, I'm going to say a few short words about Timber Development UK. TD UK was formed in 2021 from the merger of the Timber Trade Federation and TRADA, the Timber Research and Development Association. That created the biggest supply chain body for timber in the UK. We span all the way across the board, from sawmills to specifiers, to designers, architects, engineers, craftspeople, and everyone in between, for everyone working with wood. You can see our three key missions here: to connect the supply chain, to lead best practice, and to accelerate a low carbon future with a fantastic low carbon material that is timber. And here you can see some of the ways in which we do this. One of them is, of course, via webinars like this one. Another one is our magazine designTimber, which members all receive, covering all the latest and greatest in timber design news. You can see an example of one of the many useful publications from our knowledge library there, the Moisture Management During Construction. It's recently published, an essential guide really for anyone working with timber buildings. Another example from our knowledge library is there. That's one of our many knowledge sheets. We've got over 120 of them now. That particular one is about using structural insulated panels, but if you want to boost your timber knowledge, please do visit our knowledge library and you'll see knowledge sheets on all timber topics. We also have a burgeoning case studies library, and there's the recent prize-winning Cotto House, an absolutely beautiful private building. So do make the most of all the many resources that you'll find on our website. And if you're not already a member of TD UK, we'd love you to join. Many of our resources are free to all, but there are plenty that are member only. Last year, we launched Find Your Timber Partner, for example, which is effectively a shop window for all our members. Members get their own bespoke page where they can communicate with the rest of the timber industry and show potential new clients all the services and design offerings that they have. So now I'm going to hand over to Adrian, who's going to kick us off. I just want to draw your attention to the Q&A button. If you go to the bottom of the screen, you'll see the Q&A function. So please do ask questions throughout this presentation. We'll have a little bit of time at the end, but not very much for questions. So do make use of that Q&A function. But now over to Adrian. Adrian, I think you're muted.
Afternoon all. Sorry about that. Hopefully you can all see that. So Skylon Park, just to give a little bit of context to the project firstly, part of NMITE, which Ben will speak about, but the NMITE was the UK's first new higher education provider in 40 years, so a brand new institution. And NMITE engaged Speller Metcalfe as principal contractor, Bond Bryan Architects as part of our team in August 2020 through a two-stage procurement route with a brief to take on the development and construction of the Centre for Advanced Timber Technology, with a current design then sitting at RIBA Stage 3, which Aditi will talk about. But we quickly realised that the original scheme was some £4 million over budget relating to our cost plan. So redesign and value management was immediately required to get the project on track. Then in October 2024, a secondary building need was introduced to the brief. So the Centre for Advanced Manufacturing And we quite quickly realised as a team that we needed to reset to REBA stage 1 to allow amalgamation of these two building functions. So that led to a very speedy design process. We were under pressure. This project was funded by the Local Enterprise Partnership, who you may be familiar have strict sort of spend deadlines relating to calendar years. So that drove an intense period of activity to get REBA stage 1 to 3 completed to allow a planning permission submission in mid-January 2021. So just reflect on it as he takes you through the design development, because the collaboration to achieve that was immense, really. To do that, early involvement of an expert supply chain and not least hybrid structures with Greg here today was absolutely essential. And this all led to a successful build completion by August 2022. So before we get into the more technical aspects, just give you a bit of a context of the project, and I'll hand over to Aditi now.
Thanks, Adrian. Hopefully you can see my screen. Okay. Thanks, Timber Development UK, for inviting us to present this. So I'm going to talk about the Centre for Advanced Timber Technology, which is also known as the NMITE Skylon campus. So as Adrian touched upon, the building is for NMITE, so the New Model Institute for Technology and Engineering in Hereford. NMITE's a relatively new organisation. Again, as Adrian mentioned, they registered as a higher education provider in August 2020, and that's when we, Bond Bryan, along with Speller Metcalfe, came on board on the project. And NMITE provide higher education in engineering, and they ensure that students are work ready upon course completion. So their teaching model very much emphasises learning by doing, working alongside industry partners. So the time when we came on board on the project, NMITE already had a city centre building, but they wanted to create a purpose-built building to accommodate the Centre for Advanced Timber Technology, which is one of their key courses. So just touching on the background a little bit. From the outset, the brief set out for the building to provide essentially 3 types of spaces. So it was to accommodate studios, which are classroom type but flexible teaching spaces, breakout spaces for informal learning, and then a workshop, which is a factory type space for making. Timber was always to be a key component of the building, but with NMITE being quite a new organisation, there was no formalised brief as such, which was continuously evolving throughout the early design of the project. But as Adrian also mentioned, the budget was extremely tight, but the client were always very clear that they wanted an exemplar building that showcased timber and acted as a teaching tool for the students. So it's, as I mentioned, the site is in Hereford. For those who don't know, that's close to the border with Wales. And the site is on the northwestern edge of Rotherwas Industrial Estate, also called Skylon Park. So that you can see in the red and the image on the left, the location of the site. It's and it's about 1.5 miles southeast of the city centre of Hereford. So where it says Hereford, that's the centre of the city. And the image on the right shows you the nature of the site itself and its immediate context. The site is accessed via a new road that connects to the A49 that goes directly into Hereford and beyond. And this is what the site looked like initially. So it was an overgrown plot of land close to the River Wye. North of the site is low-lying agricultural land, and the south and east is the Hereford Enterprise Zone. The only neighbour was the Shell store, which you can see in the top left of the top image. That's a building that was built during the First World War, and that's now been renovated into an office space. And then the site was relatively level, as you can see, but there were a few minor undulations. There were approximately 75 trees on and along the boundary of the site. Majority of those were low quality. There were a few that were high quality that were retained. the main vehicular access is through the shell store. So where you see the two people in the top image, that was the vehicular access onto our site. There's also a cycle and pedestrian path that's to the rear of the shell store site that connects to the city centre. Now, when we talk about value on this project, it's really important to understand the previous scheme for the building. So when the Bond Bryan Speller Metcalfe team were appointed, we were to develop a planning approved stage 2 scheme through to completion. And the scheme that you see on screen now, that was the previous scheme designed by Oakrides, who are specialists in bespoke oak framed buildings. But when this scheme was costed, it came in at 9 million, and the budget for this scheme was actually 6 million. So we were severely over budget, and we required that drastic redesign to make the project viable again. So we began appraising that scheme, the stage 2 scheme, in terms of adjacencies and in terms of, and we looked at numerous approaches. Some of them are on screen now. So we looked at form and materiality to inform the high level costs of the various options before we sort of went down the route that we went down. But actually the costs, when they came back, suggested the only viable option really was an almost complete redesign, going right back to REBA stage 1. Now, whilst we were doing that exercise, NMITE were also developing a scheme for a separate CAM building, so the Centre for Advanced Manufacturing, which was to be designed by others, but was to be built next to the CAT and built concurrently with the CAT as well. But whilst we were having discussions with the client, it sort of became clear that the budget was quite tight to be able to achieve both, and the client's aspirations for both buildings would be difficult to achieve within that budget. And so when we came on board, we sort of suggested combining both buildings into one, and this would provide the client with efficiency, but also the best value, whilst being able to achieve that exemplar building that they aspired to as well. And fortunately, the client agreed. So then we sort of went back to REBA stage 1 with this new brief of the combined CAT and the CAM, and then we began appraising the adjacencies and the configurations. So we looked at numerous options, and as Adrian mentioned, we were extremely tight on time. But you can see some of the options we looked at here. So the orange indicates the studios, the breakout spaces in yellow, and then the workshops are in pink. But whilst we were doing this exercise, we actually realized that the stairs and the lifts required for a 2-story building were actually taking up significant amount, not only in area, but also in cost. So we then suggested, well, why don't we look at a tall 1-story building instead? This would give the client a little bit of presence on site, but also more importantly, be within budget. So we went back to appraise the brief again, and we looked at what was affordable. So we went from the Oakride scheme of 8 studios down to 5, but we now had 2 workshops, the CAT and the CAM. We still had the breakout spaces, but ultimately we collectively wanted each space to work a lot harder so that we could get that value for the client. So obviously the building layout itself was important, but the approach to the site strategy also contributed to providing the best value for the client. So when we're thinking about how we were going to utilize the space on site, environmental sustainability and optimization of that site were key drivers for the site strategy. So we positioned the building closest to the shell store, which is shown in the diagonal hatch on the left of the diagram. And this allowed us to minimize the hard landscaping through the new roads, the parking, the service yard that would be required. And it also allowed ease of access to and connection to the existing access routes. And then we introduced some external green areas for connection to nature because we wanted to retain as much of the quality of the existing site as possible. And then finally, we really looked at the orientation of the building as well. So we orientated the building, locating the studios, which are at the top of the screen, away from the south to manage heat gain and to reduce energy demand as well. So By combining those two buildings, we maximize the use of the site by containing this development to the left-hand side of the plot. So you can see that the grey area is what was left undeveloped, open for potential future expansion should the client wish to do so. But this reduced the development area by roughly half, which meant that the client only really needed to purchase that left-hand side of the site, thus providing them with further cost savings. And then when we look at the building layout itself, we simplified the building into two key elements: the studios and the workshops, which we referred to as the studio block and the workshop block. And this language was really tied into the structural frame of those two blocks and the materiality, as well as the functions. So on the diagram you see in the top left is the main entrance via the studio block. The studios are then all grouped together, facing out to the northwest. They're shown in blue. These then connect to the breakout space in orange, which then look into the workshops, which are yellow. And then the ancillary spaces wrapped around this organizational diagram. And this gave us a really simple rectangular form, which is the most efficient also from an energy perspective. And then this translated into the floor plan that you see on screen now. And this has the studios lined up along the top of the screen. The first three studios from the left are divided into two, can be divided into two with a separate access for each. And the two studios in the top right-hand corner are combined with a movable partition in between to create one large space. And then at the bottom, we've got the two workshops, one each for the cat and the can. And then within the workshops, there's a mezzanine above the workshop ancillary spaces, one half of which accommodates plant, whereas the other half provides that a safe access route onto the roof via a stair. And the lower roof level, as this is called, is the roof to the studio block, which you see in the photograph on the left, which has the roof lights to the studios, the photovoltaics, and a bit of plant as well. So once we had the layout agreed, we started focusing then on the form and the materiality of the building. The concept was always to try and borrow from the industrial typology of the surroundings and the neighbouring shell store building, which has that very distinctive sawtooth profile roof. And we explored some of this in the sketches on the right-hand side. The form of the workshop block was always seen to be sawtooth because we wanted to address the industrial context around us, but it was also the most efficient functionally. Ultimately, we wanted the building to be simple in form with a high quality of detailing, which is sort of encapsulated in the sketch on the left, which is what we developed into the build scheme. So given the nature of the site and the relative flexibility and orientation of spaces, we wanted to ensure that, that maximum passive design principles were applied to the building to reduce those energy costs. And the studios were always going to be the most densely packed spaces within the building, so we needed to manage that heat gain. And so we proposed these to be rectangular with the short edge against the facade to minimize heat gain, which we can see in the image on the left. The orientation is northwest for the studios. And then to maximize natural light into the spaces, we introduced north lights running along the length of the studios, which you can see in the central image and the diagram in the top left, which created these well-lit spaces, reducing the demand on artificial lighting. And because of this function, we then created this sawtooth form over the studios, which was driven by this function. And these elevations really show you that form. So the top elevation is one to the studios, where you can see the sawtooths at the top to the north lights and the workshops beyond. So in terms of materiality, as I said, timber was a really, really key component of the building design. So we maintained this focus on the use of timber, both internally and externally. We wanted to showcase as much of it as possible. So we looked at various precedents that you see on screen for the whole building, for the frame and the external facade as well. And initially the plan really was to have a full timber frame and timber cladding across the building. However, the budget did not allow for that. So instead, we began exploring a hybrid frame and facade solution. And rather than see this as a negative, we actually saw this as an opportunity, because to achieve the large, clear spans in the workshops in timber, we would have required glulam beams in excess of 1 meter depth, pushing the envelope even higher. So actually, it was more efficient in terms of material use, cost, and space to move to a steel frame within the workshops. And so we arrived at this hybrid solution where we've got the studio block in timber frame in the image on the left, and then we've got the workshop block in steel frame, which is the image on the right. And we continued this language externally as well, maintaining the timber cladding for the studio block, but then cladding most of the workshop block in metal cladding. And the diagram in the top right really explains this driving principle for the building. We have a tall single-story element with 2 distinct parts, but with a shared language. So the red dashed lines indicate the timber in frame and in cladding to the studio block, but it extends out to the front of the cat workshop to give the building that cohesiveness along the front elevation. And then the blue dashed indicates anything that popped up above that timber base, and that included the north lights of the studios to be metal clad, but also represented the steel frame within the workshops. And we strongly protected this diagram, and we kept coming back to it to ensure that we didn't diverge from this driving concept. And for the studio block, we left as much of the cross-laminated timber and glulam beams and columns exposed so that the building could be used as that teaching tool for timber technology for NMITE. And so this was the agreed scheme, which demonstrates the principles of that diagram on the previous page, where we have this timber base that wraps around the studio block and extends to the front of the workshop, but with the rest of the workshops in metal cladding. And so talking about the cladding, when we were designing this, we wanted it to be really simple. And so we used a language that allowed sufficient variation to make the facade interesting, but also functional. So the principle was really to use timber verticals in 3 sizes, which you can see in the images on the left. So the smallest batten that we used was for the bulk of the cladding element. We then introduced a medium timber size that was used to create interest within the long workshop front elevation, and also to provide some framing at glazing. And then the largest timber size was used at grid intersections. And then these were then framed by a head timber that ran horizontally across the top. And for the west elevation, which is along the studios, we required some solar shading to manage the glare. So we used the same language, and we actually just pulled apart the smallest batten size and ran it over the front of the glazing to provide that solar shading, which you can see in the bottom left photo. And this really continued that same language throughout the whole facade and gave it that cohesiveness. When looking at the timber specification for the cladding, we also wanted to use a species that was inherently durable to prevent the need for ongoing maintenance and any additional treatments or coatings. So we chose larch, which is one of the most durable timber species for use within timber cladding. In terms of ensuring that the timber was protected, we made sure that all timber elements were off the ground. So for the cladding elements, this was a minimum of 150 mil above the external ground level, which you can see in the images center and right. And then for the structural columns at the main entrance, in the image on the left, we raised these to be 300 mil above external ground level. And we worked really closely with the structural engineer and with hybrid structures to ensure that that detail was as discreet as possible. So we really recessed all the plates and things, giving it that really neat and tidy aesthetic. And with the budget being so tight on the project, we really wanted to ensure that key aspects of the design were retained as we developed the scheme. And one of these was the columns to the main entrance, which we wanted to be as invisible as possible. You can see in the image on the left. And during the design stage, we realized that we needed to put some plant onto the studio roof. And this would have meant that the roof to the studios would have needed to be 60-minute fire rated. And due to the char rate of the timber, the entrance columns were actually turning out to be quite chunky. But then when we looked into the problem a little bit laterally, we realized, well, actually, if it's not going to be used as a means of escape, it doesn't need to achieve that 60-minute fire rating. So we tried a different approach, and we actually hung the plant off the steel frame of the workshop, so it didn't sit on that studio roof. And that meant that we could then slim down those main columns on the entrance, giving it that neat aesthetic that we were after. And that really, that's one of many stories on this project of really fantastic collaboration between the architect's vision and how we made it work together with the frame subcontractor hybrid and also the structural engineer. And then sort of just last slide from me, I think when we're working with timber, it's so important to get the coordination right really early on, especially if the timber is exposed as it was on CAT. So this was one of the key elevations. It was fire rated, so we had a lot of penetrations coming through. This is the wall between the studio block and the workshops. And we really spent a lot of time ourselves and with hybrid structures to ensure that we got the sizing right, the positioning right, and that everything was going to be pre-cut, not needing any cutting on site. So really taking advantage of that off-site manufacture process. And this drawing really shows all the coordination that took place prior to site assembly. And I'm gonna finish on that.
Thanks. I'm just jumping in there to remind everyone to make good use of that Q&A box. I can see we've got a question down there, but feel free to ask as many questions as you like. Thanks.
Hello. So I'm Greg Cooper from Hybrid Structures. Oh, have I shared my screen? Yep. So I'm Greg Cooper from Hybrid Structures. I'll take you through the building and our involvement in the structure and point out some things that we worked with the team on. As been said before, there was a significant amount of collaboration all the way through this, both from the end client, which we often aren't privileged to do in talking about things and seeing the vision, but also right through to, as said, the biggest one of these is definitely the budget and working on where small savings and gains can be made, two things can be rolled into one, etc. Those were the little wins, and I'll take you through how we involved. As you can see there, from vision to ultimately on site, and the bit in the middle on the model is the bit we did. It looks pretty the same to me, so pretty pleased with what we delivered. So as I said, we got involved very early, and we always talk about early engagement and how it can use, but you can see how the building evolved. And this really was a two-way process in terms of feeding in how to make things simple and working out the number of components, working out how things are put together, how they are manufactured in the first place, allowed for a more rounded structure and a more rounded use of the materials. And one things we were asked extensively on was, be honest with what you're doing. This is a manufacturing for timber building. So whatever you're doing, let's make it so people can understand it, see what's going on, understand it, and then adopt those practices in the future when people learning in this space go out to the wider world. As you can see there, that the building has evolved. And I'll talk through about a few critical items that may not be apparent to start with, but were fundamental to part of the success of the building. So as can be seen there, that is ultimately what we delivered. That's the cross-laminated timber acting as the roof, acting as the walls around the perimeter, etc. And it looks very simple. And these are our things we do day in, day out. One of the key things we did here was we worked closely with the architect in making sure these blue elements were actually sized to the maximum size a panel could be to get it to the UK and get it onto the site. So what that did is it enables those blue elements to come to site as a single panel and lifted in as a single element. If those panels although the length of that would have been 10, maybe 20 mil bigger, that would have meant we would have needed tens of thousands of temporary works to install it. Significant amount of screws, strengthening items to get the whole thing to work. But through collaboration, the angle of the windows, how things all work together, we were able to influence the design to how it is. The little bits in blue between the windows, as it didn't match the photos you've seen before, they were cut out afterwards. So they were removed, they were transport pieces that were put out locally. But as I said, it meant for a quicker, faster build. Another item which we spent a long time scratching our head around was the bifolding door. That some of the spaces opened up into two spaces. With bifolding doors, they're top hung. And again, one of the visions wasn't to take away or detract from the spaces. And we spent a long time trying our utmost to get this to work in timber, but the physical size of that the beam needed to be in timber would have detracted from the space that the architect and the client wanted. So we had to mix the materials in small areas like this, where we use structural steelwork to ensure that the deflections were limited and the item or the door could work throughout the life of the structure. As you see there, it's just a single beam, goalpost frame, tied into structure to make the structure work. And the third thing we touch on is the larch at the front. Now, very eloquently discussed how that all works, but the other thing as well, we spent a long time talking to the team about the maintenance of these in the long term. Yes, larch was chosen, but the larch will still need maintenance over its life. So the whole structure in this canopy was designed to be able to be propped and potentially remove the columns and quickly replace them without significant impact on the usage of the structure. So the maintenance strategy was there, the long-term CDM requirements of the building was taken into account, so it could be replaced. And like we spoke about, the width of those was absolutely key. The thinner it is, the quicker they need to be replaced. So during the life, we've estimated they probably need replacing every 10 to 15 years by the client, just to make sure they're getting the maintenance and the long-term life out of them. So the whole design, how it clips together, was vital. The other part of the brief, as far as we were concerned, was to show different types of connections, different uses, how things go together, etc. There's some examples there about load bearing, simple screw connections, off-the-shelf brackets, bespoke brackets, lifting, how things go together. So lots of different concepts were used throughout the building. It wasn't just build me a building because of the cost. It was about showing the journey and also showing different uses of technologies, because ultimately it was supposed to be a living lab, so people can learn off it going forward, not just the day it's finished. Things can go around and be pointed out. So as with all builds, things go in, and buildings are made up not just of wood, they're made up of lots of components. So to give people an idea, in total, we use 3 different types of wood on this. We use CLT spruce, glulam spruce, and glulam larch, and they're the quantities. Approximately 350 meters cubed of timber went into the project. On top of this, there's 3.1 tons worth of steel, 275 brackets, Eurotech plates of 60, and steel plates, as you can see in the top right corner, of 50 number. But also lots of screws, lots of bolts. 42,000 nails went into this job to physically make it work structurally to stand up. That's a lot of nails, but fundamentally, they are the components that connect everything together. So in total, there's around 50,000 screws, nails, and bolts that go into this job to make it work. And then on top of that, we always have items such as DPM, packings, tapes to give air tightness, sealant, end grain sealers to protect the CLT as we go, tubes of sealant to make sure the air tightness and packing, etc., just to physically get the building to work. So as he says, there's the base material. In total, we were approximately 7 weeks on site, 1 week's prep, 5 weeks main erection, and then 1 week to finish off to make sure the connections were fire rated, fire safe, etc., to get those to work. In terms of the construction, it looks a beautiful site in the middle of nowhere, but one thing that was missed is there's a mains drain that runs right through the middle of the site where you can see this blue line, which means the crane can't go on the footprint of the building. It was a floating slab. So we had to build the building in phases. The structure as it was built is actually quite a unique structure. It works like a house where everything wants to thrust out. So until everything's tied and put together, we had to build a ring beam with the glue limb and then lay the CLT on top with a significant amount of temporary works to prevent it from spreading. Ultimately, that all worked. We couldn't get the crane to work here, it was over there. But ultimately, a 50-ton crane, we were able to erect the whole structure. So some images there. You can see heavy props in here to erect it. We haven't gone OTT on the temporary works. We don't need that many props. That's more because of the thrust load from the road during the construction phase from the roof. So as it's being built, we put the props in, it's safe, it isn't going to spread, and it's going to tie itself all together. The black sheets there were to reduce the UV staining, reduce the finishing off works and the staining on the site as well. But they're there to protect the timber, both from the weather and the climate. You can see at the base of the image, it rains every day in the UK at the moment is what it feels like. So taking care of your timbers, obviously pretty vital. Other images there, the work's progressing, a few discrete posts behind the glazing, and then some finishing off processes. And you can see in these top images where the roof lights are about to go on. And then as the roof lights progress, and then a nice sunset when it was all complete, our elements of the works. So that is myself wrapped up. So thank you.
Scott, I'm just going to talk a little bit about the construction phase, delivery and lessons learned. So bear with, I'll just share the... Okay, hopefully everybody can see that. So just talk through the construction phase and how that went. So imperative with any structure, but is the management of quality, and this is become even more important with the advent of the Building Safety Act in 2022. But in construction on this project starting in April 21, we were managing quality issues to incorporate a digital golden thread through inspection test plans and defects management involving geo-tagged record photos that recorded any issues. We were using Fieldwire software to do this. There's obviously lots of software platforms available, but that allowed us to integrate with the supply chain through the build process to look at the critical inspection test plan points and to record that centrally, so there's a record of the build and active management of it. Just an example here of an inspection test plan for the timber frame structural panelling system, so you can get a bit of a feel for the level of detail that we were going to, and incorporating the design drawings, incorporating checks, craneage lifting checks, incorporating installation checks, bespoke really to the project, but a very thorough record of quality control going on, and sign off again required by the subcontractors to give that ownership of quality and our own site supervision team. But what you don't see behind these inspection test plans is the wealth of photographs as well. So within the project quality plan, there's thousands of photographs of installation and a digital record. So I think a really good precursor for digital golden thread and Building Safety Act and responsibilities there. Sustainability was very much woven into the fabric, so a hugely fabric first approach to achieving excellent U values and air tightness performance, translating into an EPC-A with potential for future net zero in operation. We got loads of roof space for further PV panels, but we put as many on in this phase as we could afford to reach that EPC-A, but did do some calculations around future carbon offset, and the roof is designed to take that PV load. We were under something called a Green Apple assessment, so it's bespoke to Herefordshire Council, but broadly aligns to BREEAM, and achieved a 90% score under that holistic sustainability assessment, and a final air tightness result of 1.3 air changes per hour using a passive house methodology, not a UK building regs methodology. So some of the lessons learned. Aditi and Greg have both mentioned the early detailed coordination of building information modelling, and I see Lee Tavis, who was involved in the project, has commented in the Q&A. Lee was involved in the MEP design, but there was a huge amount of detailed work involved in that, and I think compared to projects that I'd been involved with previously, there was a need to bring that forward in the REBA process to enable production timelines and manufacture, but to give that certainty that the CLT and structural frame was coordinated. So I think we had to think outside the box a little bit as to when the deliverables and the detail were needed in the project delivery. Education of the workforce on site. So, and not just this project, but other timber projects that we've delivered. There's a bit of a misconception that this timber is going to get covered up. It's not the finished article. I'll draw on it. I'll drill into it. No, thank you. That's not great. So, you know, education of all the workforce. There's a picture there of a toolbox talk going on outside the site office, I think is key. Sequencing of the roof works to ensure water tightness. So we've got the sawtooth roof, but we'd also got fairly flat sections on it, and ended up program-wise putting that up in the middle of winter months. So to adhere roof membranes, we need dry substrate, and we've looked in collaboration with Greg and roofing subcontractors. Could that be factory pre-applied for a better quality project? It's not something that we've solved yet, but it's certainly a lesson learned to take forward to other projects. Application of fire retardant treatment for the spread of frame. So when's the optimum program point? We've got to do it when the moisture level of the CLT is right, but you also need to do it before you whack a load of MEP infrastructure up. Otherwise, it's quite difficult to install. And design for disassembly. So Greg has mentioned the future maintenance, but that column facade at the front, a lot of work into making sure that can be replaced easily in the future, and with the timber cladding that Aditi's described. Achievements, so capital cost, 1.7 million in value engineering, or value management as I'd prefer to call it, achieved to reach the £6 million capital budget, and a build cost achieved for £2,180 a square metre. Obviously the large workshop space helps that cost efficiency, but I think in a time of rising costs, exceptional achievement to do that, and aligning the budget and the flexibility of the building to the output. A local spend of 75%, which we're really proud of, within 30 miles of the project, for the supply chain value. And a huge £11 million social value spend achieved measured using the National TOMS framework. We've touched on significant collaboration, and Ben will talk about Living Lab, but that concept started during the construction phase. And all in all, award-winning project, Construction Excellence National Award winner in the value category. So just a few pictures there of things that we were doing on site at the time. So that's my brief overview of the construction phase, and I'll pass over to Ben.
Great, thanks, Adrian. I'm just going to share my screen here. Hopefully you're all seeing that. So I actually get the, as a lot of architects and engineers will probably know, you don't always get the privilege to stay in the building and see it occupied. So I get to occupy the building and work in it on almost a daily basis. So I guess my purpose here today is really to talk to you a little bit about what we do, what we use the space for, and what we teach within the building. And to do that, I really want to start off by first outlining why the building is so important to us, not only as an institution, but also as the construction sector as a whole. And the point being really that conventional construction practices at the moment have inherent inefficiencies. Not to say there aren't lots of innovations within the conventional construction approach, but the way we see it is we need more people, more professionals working in more modern methods of construction and looking towards the future. So there is a case for change. As we know, there's an increased housing demand. England alone, I think, is circa 340,000 houses a year we need to build to keep up with demand, and doing it in more traditional ways may not be the most sensible approach. So building a curriculum that we can upskill people in more modern methods of construction is fairly vital. There are environmental considerations we need to think about when we're talking about conventional construction approaches. This is due to building quality, material use, and potentially inefficiencies in the construction process. And all of this to say there is a building necessity for improved building quality and methods. So there is an urgent need for modernisation in the construction sector, and we can achieve this through leveraging new technologies as they emerge, steered towards more off-site construction, the use of biogenic materials, which I'm sure we're all advocates here today, and more automation within manufacturing. And ultimately, this means developing more of a design for manufacture and assembly mindset. And generally, this comes in the form of modular or panelized construction. So the image there, interestingly, on the left-hand side, so that's the Gen 0 classroom prototype, a prototype building for the Department of Education using homegrown Sitka spruce, CLT and glulam, and it's a prototype building that we have inside the Centre for Advanced Timber Technology, and we use it for teaching. So it's been erected at the moment, had been erected using a HIAB, but we do have gantry crane capabilities which will be coming in the future. So timber and construction, this will come as no surprise for most of us here. I mean, the advancements in technology are phenomenal. What that's really done is taking a rise to what was once considered to be an outdated material and bring it once again to the fore as a viable construction material. It's versatile, of course, but you can see that through the presentations we've seen just now, used both for structural and for cladding purposes, and of course for aesthetics. And ultimately, if properly managed and properly harvested, it's sustainable. All this to say, we have a selection of engineered timber products that we can use today, from panels, sheets, beams, and trusses placed into panelized or volumetric construction, which is all very well and good. But how of course do we achieve more of that within the construction sector? It's all very well and good us shouting from the bottom up, but ultimately it needs to come from the top down. But luckily enough, in 2023, we saw some movement in that direction from the UK government's production of the Timber Construction Roadmap. To get to the point, really, the most important thing for us is this section here, so increasing skills, capacity, and competency across the supply chain. And that's really where we come in and where the Skylon campus shines. There are some challenges. The construction skills gap, of course. Construction innovation is always on the rise, which is fantastic. But with education staying fairly stagnant, long-winded, there are some issues there. What was needed is an intervention for upskilling and reskilling of industry professionals in real time, so we can adopt these new construction methodologies. And this is where the Skylon campus and the Centre for Advanced Timber Technology is really a crown jewel really in NMITE. We were able to create courses so we can make flexible education options for those that want to upskill using accessible learning platforms, which means possibly doing things online. Micro-credentialing, breaking things down into small bite-sized chunks. So those that are coming to us for some education and for upskilling, they don't need to go for a long-winded course. They can learn specifically what they need to learn and then go back to work. These can be stackable, which ultimately means that we can create bespoke learning paths as well. And it needs to be just in time. And what I mean by that, it needs to be fast, short, and immediately applicable. And this is what that might look like. So here's a diagrammatic example of how that may look. Taking a current industry professional, using micro-credentials, teaching relevant competencies for the new role at the correct level, all of which have stacked up to create these bespoke learning paths, which ultimately creates industry-ready workers ready to deliver the sustainable built environment. We like to do this as challenge-based learning. I think that's part of the brief right at the beginning. We heard about that. We like to do things as hands-on as we can to ensure that the students are getting those haptic skills, those hands-on skills. If that's possible, virtual scenario, online challenges as well. And of course, it needs to be applicable and practical. Just to kind of bring this home a little bit and to make this more real. So this is Dan. I'm sure he won't mind me using his images in here. But Dan was a local carpenter. He came to us with an interest in broadening his understanding of sustainable construction and design, and he attended one of our timber engineering and design courses at CAP. So himself and his team, they built this structure which uses standardized components which are interchangeable, it's extendable, it's collapsible, and it's a mixed medium project as well. It's been used CNC for some of the components and hand cut for others. So the images that you see there are inside the factory workspace, which is a large open workspace which we can use in any which way we choose, it being so large and flexible. A few other images there which we're quite happy with. As a few of our timber engineering and design students working in the space. We have a wide range of students that come to us for upskilling across the sector, which is really great for stimulating communication and collaboration across the sector. And a few more images there of some other students. These guys came down from Scotland, and the interesting thing about this is the workspace that we've created within the factory, and this is just one mode of many that we can create within that factory space with electrical outlets at the right places, and with a wide open plan area. We can able to create whatever we need for whatever scenario that we need at the time, whether it's being manufacturing components, if this is for conferences, student projects like you see here, or prototyping in other means. So our courses range. We have a large array of courses that we provide. This is just a few, but we have timber materials course from source to building, timber technology, so design, engineering, and construction. And even retrofit is, and we're understanding the requirement to upgrade the building fabric of existing buildings, our existing housing stock rather. And then finally, we have our BSc in construction management, which is due to commence in 2025 this September. And really, the idea here is to teach sustainable construction methodologies and management, and prepare students for a life of as a modern construction professional. And here I've highlighted a few of the course modules, including materials for the built environment, sustainability and construction, industry placement, digital technologies for retrofitting and building management, life cycle, and circular economy. And really the final slide for me, because I think I'm almost bang on time, is the Skylon Living Lab. It's been mentioned a couple of times, but of course the Skylon is what we call a living lab. Not only do we use the building as a place where we can show our students more modern methods of construction using mass timber, and we can point out various components of the building, but it's also monitored. And what we're trying to develop here is something more akin to something like a digital twin. So we've got a series of sensors throughout the entire building, which is monitoring the moisture within the CLT. So we can gather data there. And we also have a weather station on top of the roof, which we're gathering data there. So we can sort of see the correlation between the weather patterns and the moisture meters to see if there's anything there. But ultimately, so Skylon for us is a teaching asset, and it helps students with data-driven decision making. And we can teach about building performance, and it's real-world and challenge-based learning, which is what we're all about here at Skylon. And ultimately, what this all does is helps bridge the gap between theory and practice. They get to see it in real life and see it in person. And that's it from me. So thanks very much.
Thank you very much, Ben. And thank you very much to the entire panel for a really, really good webinar. I can see you've also been busy answering some of the questions in the Q&A. We do have, I think, about 3 minutes to answer further questions, but I can see there were several questions asked in the Q&A about the factors that brought in steel, with I think the overall answer really being it down to spans and the cost considerations there. So do have a look at the Q&A questions and answers there. One thing that I wanted to ask, just looking at the pictures, is about acoustics. So I was seeing lots of hard surfaces, lots of footfall. I was just wondering if anybody wanted to say anything about acoustic considerations in the building.
Yeah, I can jump in. So we did undertake, we had quite a lot of input from the acoustic engineer, and the rafts that you might have seen in some of the images, they are all acoustic rafts, and in the studios themselves we've also got wall acoustic panels that are sort of above the line of those rafts, so not easily visible unless you're looking for them. So they're all integrated, and actually they perform pretty well, because we did kind of go belt and braces on the acoustics. I don't know, Ben, if you wanted to jump in terms of using the building.
Yeah, no, it's I can say that we've, I mean, I think the positive thing to say is that I haven't noticed the acoustics in there, which is what you want to hear, I suppose. It's yeah, it's pretty good. It works well. Yeah.
Great, thank you for that. Just see one unanswered question that's just popped up in the Q&A, asking if there were any special details for the CLT/glulam so that they work well with other systems. For example, the roof slabs/roof waterproofing. And following on from that, any considerations in preventing staining, weathering, or degradation of the timber frame? So I don't know if anybody wants to chip in on that. I think somebody else in a previous question had asked about treatment when it came to the exposed CLT. So I don't know if that's related. If anybody wants to say anything on
I'll
those.
jump in on the roof details, if I can, but I think on reflection, the sawtooth roof design and the flat roof, which also had cut to fall insulation on it to take water away, presented us with a much greater level of complexity to coordinate the geometry and the installation than we anticipated. And I think it's fair to say we were still solving that as we went through construction with secondary details there, and formation of gutters in between the sawtooth roof. So that's probably another lesson that we'll take away. I've not got an answer for whether the roof waterproofing can be done as an off-site manufactured process, and that seems to make ultimate sense to me, and keen to take learning on that. But
I mean, if I can just add to that, Adrian.
Sure.
The challenge with the roof waterproofing off-site, because ideally you might want to waterproof before that timber arrives on site, so it's already kind of dry. But that would there would be the logistically moving between the different parties is quite a challenge at the moment. And if the timber supplier is to apply a membrane, actually the roofing subcontractor will not then be able to apply something, because they need to, their systems work on the basis of adhering right onto the structural slab, which was the CLT. So I think there's still a bit of work that the industry, we together need to do to find a solution. But in the interim, something that I've come across recently is just any sort of CLT roof always to a fault, so you don't have some of the challenges, so the water is consistently kind of falling off that roof instead of ponding.
Thank you.
Management of moisture, not trapping moisture during the construction to prevent staining, and a lot of advice from Hybrid on the best way to do that without causing problems for the future. On the staining question there.
I'll take that opportunity as well to just flag up a few things you can find on the TD UK websites in terms of moisture in construction. If you just go onto the site and go onto the search box and type in moisture, plus the TD UK YouTube channel has some great recent webinars on that. We're slightly over time. I just wanted to just do one more question, which just was asking about cracks. Should we be worried about cracks in glulam, especially around the connection area? Is it impossible to have crack-free timber products? I don't know if anyone wants to take that.
Greg, that's got to be one for Greg.
I was just thinking that no one else is going to volunteer for that one. You'd say it's not impossible, but what I would say is it depends on the depth of the crack. Defining the crack is the most critical thing. If it's a hairline crack, wouldn't be too concerned. If it's a very large, deep crack, I would ask for a specialist to come and look at it to make sure there's nothing worse going on, is what our approach would be.
Okay, thank you very much. There were a couple more questions, which I think we will leave, unfortunately, because we are over time. But I will talk to the panel. I can see Adrian is still typing an answer to one of them, but we will get around to those questions and hopefully be able to send a few answers to all the attendees later on via email. But yeah, I'd just like to say thanks to the panel again, and I'm going to just very quickly share my screen to just tell you about the next webinar we have in the series, which is Old Schoolhouse on Wednesday the 12th of March, same time, Wednesday 1 till 2. This is a lovely project, fully clad in locally sourced English sweet chestnut, was highly commended in the 2024 Wood Awards, and you can reserve a place for that now. So yeah, thanks again. And I will bid you all a lovely afternoon. Thanks and goodbye.